And so this is the last session for today. Thank you for gathering, everyone. So I'm sure everyone is very tired, but I hope this session will be the most exciting and hardest session. So, also what you have learned today and what you have heard today? Well, we started with the Matsushita-san's presentation, and we are finishing with the presentation of Matsushita-san. So, what you have heard most, the word FT as error correction and FTQC, those are the words you heard most. So, today, I'm going to talk about FTQC. And so those top learners who are already involved in this world of fault tolerant quantum computers. And so with us today are some Mitsubishi Chemical representative from the users domain and Qmix, and for the users and hardware, software, and QuEra's Kitagawa-san. And so from the academia, Professor Todo, and myself from the consulting domain. So we have a different background and how we see FTQC and what we do. That is the focus of our topic for this session. So without further ado, so who we are, maybe we should be briefly introducing ourselves. So first, Professor Todo, could you briefly introduce yourself? Yes. My name is Todo from Tokyo University, University of Tokyo. So I'm started for the statistical physics and supercomputers and those algorithm research and applied research was my expertise. And most recently, and so quantum computing come into my portfolio of research topics. And what you see on the bottom half is what we do. And this quantum error correction, one of the hot topic for today. And so new algorithm development for the quantum error correction is one of the research topic, and also optimization of the quantum circuits, how to rearrange it and decompose it. And so using a tensor network, that data structure or the algorithm of such, this has been much been in use in the physical world. And I'm sure that you also often heard about this in a quantum computing world. So how we can use it for the quantum computing and optimization or the error correction. So that's what I focus on recently. So next page, please. And also, the quantum software project that I'm involved in recent years, those are shown here. And so SQAI, Center for Innovation for Sustainable Quantum AI. And as you see here, well, AI, machine learning, and quantum simulation, and how this can be achieved using quantum computer. That is the main focus of this project. This is 10-year project. We are in a second year this year. And another one is this is about the education relevant project. And we have a quantum software endo chair, and that was launched within the University of Tokyo. Tensor network and sampling, combining those two. And so we develop quantum machine learning and development of application. So tomorrow in the afternoon, and Dr. Okubo from this endo chair program of the University of Tokyo is going to talk. And also, there is another project relevant to the human resource development. Thank you. SQAI, well, Mitsubishi Chemical and Deloitte and Quemix are also involved. QuEra is also involved in the SQAI. And I'm sorry, QuEra is not part of it, so you should be. So what kind of companies you would like to work with? Do you have any expectations? Currently, there are about 30 companies involved, and some universities, of course, and city government like Kawasaki City is also part of it. So from the company's point of view, those IBMs and OPC who develop quantum computers are part of these initiatives. So and Quemix, who develop software using quantum computing, is also a part of it. And Although they're not using quantum computers yet, they need to learn, and for the sake of the future development, that company is also a part of this initiative. So wide-ranging entities are involved, and so it doesn't matter the background. And so the nationality doesn't matter, so the overseas company can be a part of this. So this could be the gateway to Japanese consortium. Could I call it a consortium? So we are working towards establishing consortium. Thank you. So next.
Please give him a round of applause. So next up, from Mitsubishi Chemical, we have Ji Gao. From the beginning, he has been involved with the quantum projects, and we have worked together for a long time. Thank you for inviting me today. I work for Mitsubishi Chemical Group. I'm a researcher there. In terms of quantum computing, 2018, a company participated in Quantum Hub, and with that, we started our quantum research. Before that, we used HPC to work on material informatics for large-scale project. So this is the very first quantum research. Lithium chemical reaction calculation, for example, has been done IBM together with Keio University, and I was involved in there. Next, this is about our company, the current quantum computer project, the overall picture. We have wide range of joint partnership, including academia, industry, and government organizations. Academia, Keio University is one university, University of Tokyo, University of Toronto, as well as AIST. They are all research partners. For private companies, we have IBM. We do use the quantum computer for our research. Currently, we are utilizing domestic quantum computer produced by Fujitsu. And for FTQC, Quantum is a very famous company in that area, and that's our partner as well. And we also have national projects involvement, NVIDIA, and also QuEra are hoping to become a partner. So today is the start. And SQAI, Professor Todo earlier introduced, and Professor Sato of University of Tokyo, we are working together. And there has been wonderful outcome from this association, QStar, and other consortiums. We are a member of these associations. So, Sakochi or Chigao, you have been involved from the very beginning. Just one company is involved in a very wide range of activities and projects, but there may have been winding road that you have passed through. So I just wanted to ask you, what motivated you to move on quantum computing? So quantum computers have made progress, much more progress than I had expected. In 2035, I thought maybe we could possibly commercialize this technology, but I wasn't sure. But every year I have seen a very positive outcome from research. It gives me confidence. Especially last year, QuEra, there was a major jump. It really accelerated our progress to get to FTQC. Thank you very much. You're pretty passionate. Thank you for that introduction. I'm pretty sure everyone's passionate. So let's move on to Mr. Matsushita. You had a plenary talk this morning. You made a cool presentation. this morning. So, Mr. Matsushita, once again, thank you. I'm a CEO of Quemix. My name is Matsushita once again. So, I am a CEO of Quemix. At the same time, I teach at Tokyo University of Tokyo and also belong to QST, the Research Institute. So, as a researcher, I'm very active as well. I received an academic degree with a background of material simulation, and we were developing various methods. We wanted to calculate faster and faster. We wanted to calculate more precise and more accurate. We wanted to do a large scale calculation. These were the reasons why I reached the quantum computing. It's been 5 or 6 years ago since I was involved in this area, quantum computing research and development. And this is my background.
我々 Qmix
So Quemix is a company I launched, and so developing algorithm for the quantum computers. We are dedicated a resource to this area. So when it comes to quantum computers, there are different type of quantum computers. Among all, since start, era FTQC has been a target for us from the start. We've been developing a quantum algorithm for FTQC. So today, I was able to explain some of the outcomes. And so new method for exponentially accelerating material calculations. And we have already proposed this type of new method this morning. So that was all about Quemix. So starting from the starting point and now, and you've been only focusing on FTQC, and now you start to see more visibility on the pathway to FTQC. So it's dedicated to FTQC. So next, last but not least, and so many times your company name was mentioned in QuEra, so Kitagawa-san. So now the bar is high for me to introduce myself. And so not much to talk about myself. My name is Kitagawa, and so I'm president of QuEra. And so my background is also a cold atom and so theoretical physicist. And after that, I joined Rakuten and served as executives in charge of AI. And so AI is quite a buzz now, and I decided to move on to the quantum, and I started this business since last year. And so important thing is about QuEra. So QuEra is a company that develops and manufactures a quantum computer based upon the cold atoms. And Harvard MIT professors was the founder of this company early on, and combining those technologies, we are making this product. And the mission to develop, manufacture, and innovate quantum computers that are a quantum era tolerant and scale and benefit humanity. So quite a match to the topic we are discussing today. So our quantum computer since 2022, and first generation of our quantum computer is available on the cloud already. And as Mitsubishi said, in December last year, a 48 eligible qubit together with Harvard, we made an announcement in the Nature. Next fiscal year, for the first time in the world, gate-way based and cold atom quantum computer to be delivered to AIST, so that people here in Japan can also use. So for those who are interested, please take a look. So, well, there is one burning question we would like to ask Kitagawa-san. So why, Kitagawa-san, you moved to QuEra? Well, because in this cold atom quantum computing platform research was my background to begin with. But back then, I thought it's going to take time to make it commercialized. So when I was with Rakuten, I was served as the top head of the research and investment, and there was opportunity to make investment to QuEra. And so this fault-tolerant QC possibility become visible. And I thought there's opportunity. And so I spent more time with the QuEra and also this domain, and then this confidence led to confirmation of my beliefs. So I hope that will be realized and also be discussed today. So that was Kitagawa-san. Thank you. So next, since we have so much excitement and just introducing ourselves, so error correction error, what will happen? Well, what is available to you? What do you expect to happen? That will be the first question I'd like to ask all the panelists. So from the user perspective, Coach-san, please. Kao-san, please. Using FTQC, what we can do. So future can be created using FTQC. And so what needs to happen to attain that? So if you have any thoughts on that, please. So using FTQC, and so quantum advantage can be reached, and especially the quantum calculation, that is the case. And so if that is realized, and the metal relevant, the electronic state calculation, complex calculation can be done, and that will lead to the development of new materials. It's very useful for the discovery of new materials. In addition to that,
As a matter of fact, for chemical industry, there is a new physics, new physical mechanisms to create new materials. We have this new phase arising. So new quantum physical analysis requires FTQC. And neutrons are currently utilized for material evaluation, magnetic cubic, for example. At low temperature, very low temperature, material will become superconductive. And this can be applied to medical applications, diagnosis, and also possible material for automotives. But it's very difficult to understand physical phenomena. But by utilizing QuEra's machine, we will be able to understand the neutrons mechanism for design. It's a new sustainable material that we can possibly develop. And I think it's a very positive side of our research. Thank you very much. So based on that sustainability, I'd like to ask a question to Professor Todo. So at this time of the correction, what is enabled? What has been discussed at SQAI? Sustainable quantum AI is the name we gave to this idea. Why is it sustainable? Eventually, we want to make the whole society more sustainable. But before that, AI itself needs to be sustainable. So if you look at current AI, it requires a lot of training data, and you need to have a large-scale supercomputer. It consumes a lot of electricity, but we want to avoid that large-scale consumption. For AI to continue to grow, we cannot simply extend what we have today. So we want to replace some of that with quantum to make it sustainable, to make AI sustainable. That is one thing. And to make a step toward that direction, FTQC is going to be critical. For the very first time with FTQC, we will be able to use quantum as a computer. We will be able to control quantum information completely. So that's very important. But that's one step. In terms of computation, there are multiple hierarchies in developing a computer. So we have moved one step. So you need to utilize a specific locality. So computation mechanism needs to be better understood. As a physicist, we have multi-body problem of quantum. That includes a lot of things. Could be particles and also atom as well as neutrons. And all of these have not been solved with computational physics. Monte Carlo simulation is not good enough. Sometimes they have to have a large exponential computational resources, including chemical areas. We would like to achieve this. It's, in a way, a dream that we need to achieve. And I think this is an important step to come closer to realizing that dream. So FTQC is an exciting development. As a matter of fact, we never had a preparation for this discussion. This is really a question that came to my mind, and it's very exciting to hear what he had to say. Mr. Matsushita this morning said in his presentation about FTQC can be utilized for generative AI. Can you talk about that? Thank you for that question. Yes, this morning, I showed you how generative AI can generate images. Of course, it's within the simulator. If you look at the current computer, there are two challenges. One is the limited memory and also the computation time. We are limited either one of these problems today. So when it comes to generative AI, on top of quantum simulator, quantum computing simulator, the demonstration does not show the faster speed, but we believe there is a potential that we could possibly solve the memory issue.
生 AI の画像
So, for instance, a 4K image, those fine granular image, it cannot be reproduced even using the generative AI. So, a quantum computer, if that become reality, and if you could use can realize the generative AI, the memory problem can be addressed. If so, what comes beyond that is the creative application software, like games, I think will come true for. So, generative AI, memory problem. If a quantum computer is used, I think this problem can be addressed, in my view. Thank you. So, lastly, Kitagawa-san, FTQC, and what will happen to humanity if FTQC become reality? So I'd like to go back to the Matsushita-san's opinion. So a memory issue can be addressed using FTQC. Well, Misha Lab, one of the founder, and they suppose doctoral paper issues. And so the quantum and expression of the context, quantum contextuality is more in detail. ChatGPT, for instance, context, 200,000 or 2 million, the capability of reading that. But to do that, 1 trillion parameters is needed. So that will eat up all the memories. So if you use quantum, and 1 million parameter will be sufficient. So, and contextual expression is the strength of a quantum. That was very interesting. And so roughly speaking, and so commuting A type B is different from the B times A. So if you use that theory, and so it could be very powerful tools to enhance AI. So as it was mentioned, so quantum computer can be very useful for using the AI. So if that becomes reality, I think that will also help make advancement in the humanity. So thank you for answering to that difficult question. Thank you. And so FTQC has a lot of high expectation from everyone, but as a hardware, it just went into the starting point. At the starting point, still, there are much more to do. So what needs to happen from now, or do we need to start something from now, or is it now? So and Kitagawa, son, please. So I think we should be starting it now because, and objectively speaking, quantum computer users is going to increase exponentially, but the hardware is not going to increase in a way that user increase exponentially. We have to do it early on, otherwise, when that is commercialized, we will not be able to secure resources. So we need to expect what will happen in the future. In order to secure the resources, we should start now. And another point, businesses, well, the material development companies, practical usage is important. Advantage is already visible, but 1 month, 2 months, well, if calculation takes that long, it is not practical. So in order to put into practical use, calculation has to be reduced to like weeks or days. So we have to do something to do about that. So practical usage and advantages, there is a jump. So in order to fill that gap, well, where the needs is, we need to work with the company where the needs is. So I think we are at a critical point. Unless we address this, we'll be left behind, and especially the chemical industry. And once you are behind compared to other peers, that will also impact the competitiveness of each country. So that was a very insightful comment made by him. So the things we don't need to do now, but using the tool developed by Matsushita-san, maybe that can be suffice. So if the hardware is completed within the 5 years, you can just use it that, and you don't have to do it yourself now. What do you think about this idea or opinion? It could be that could be the case, but could not be the case. We don't know. Well, the future, well, is difficult to foresee. We are not for certain. That's why we have to do it now.
金言をいた
It's very suggestive. Sometimes, if you don't act today, you will be late forever. And in terms of ensuring necessary resources, going forward, machine may be in shortage, FTQC, when it's realized, the companies who will be able to utilize that or provide that may not be as many as they should be. How can we make sure all of these can be provided? We have to have joint research. So develop partnership, yes. Develop relations, and to ensure the resources that you might need in the future. So it's really investing forward. So it's like futures trading, isn't it? Machine resources may be financial products in the future. It may be a good idea. So Kitagawa-san, this may be a business model. Maybe it makes a lot of profits. So in that case, we have to really invest early as possible. Can I also share my thoughts? Machine time. It will be more difficult to ensure machine time. So what can we do? As was just suggested, partnership could be one way. There will be investment in startups today. And I did not introduce myself, but I I'm a researcher as well. For example, take algorithm. It used to be NISC, and we are moving from NISC to FTQC. And if qubits becomes 10,000 more, so what you have to do is to compress algorithm. So software technology will become even more important in the future. And some of these software startups are emerging in the world. So working with these software companies is also a good idea, I think. Yes, I agree. Thank you. I forgot to introduce myself. Can I introduce myself now? I actually prepared a slide. So it's sort of too late, but my name is Terabe. I am in charge of a quantum project at Deloitte. As a matter of fact, I've been involved in quantum since 9 years ago as one of the first user companies. From the beginning, I have looked at quantum industry. I looked at how quantum can be utilized in business. We made investment, but now we are looking at platform other than technology and business platform, I should say ecosystem as well. Without that, Japan would not be able to prosper in this industry. If you look at the title, I think you are too busy. You have so many titles. He is really busy. He can actually interact real time, even when I was in Boston. You have so many titles. Thank you, working. Thank you for working very hard for us. Yes, I'll do my best for you to be able to have fun in this industry. So Deloitte's project, I just want to introduce project here. We are a global company. We have over 700 members involved in this quantum project. We have very good collaboration. We have about 50 members in Japan. This is a consulting firm. And users simply pay money to provide or receive services, but we really want to change the society. So we have researchers in-house. Frontline research will give us the knowledge and wisdom. With that, we will be able to help our customer companies. Tachi-san, Baba-san, who are already here in this venue, we're hoping to have good networking exchanges later on. We do have a lot of demonstration. We are working with quantum reserve demonstration with QuEra, and we also have quantum competition every year. Sorry, it was a belated self-introduction. Thank you.
ついつい
So, FTQC, what we have to do to attain that. So I wanted to share my comment. That's why I jumped in. So in era of FTQC, what we have to do from now, well, Professor Todo, what do you think are things we need to do now? Well, operation we'll have a good qubits, and then the operation will be in high quality. So once we achieve that, what will come as a problem is I/O. Whether that is AI and real world data, and how that going to be captured or linked. And so quantum computer, now you need to measure and then drop it into the bit, and so quantum state is discarded. That is a waste. So in some way or another, it doesn't have to be perfect, but quantum state to be retrieved and how to embed it into the classic, that kind of a research is necessary in my view. The keyword in that sense is tensor network. So a data structure, tensor network, for instance, a circuit simulator. Well, that area is often used, and that is so much highlights on that. But information compression, that this data structure is for that at the very beginning, and a characteristic, the property physics, and so on and so on. And so how to link quantum and the classic and device and quantum, how to link this or interfaces. I think those connection is also needed to be considered now. And another one, may I share another point of view? And as a researcher, and I'm a contrarian, so doing this and that using this roadmap, and then you can do the simulation and you can do the quantum AI. That looks good, but I don't think that will be the case in the future. In reality, like GPU 20 years ago, when that arises, and so people did not expected the current usage back then. So someone who came up with a good idea did the hacking and could be used for the computation science, and that's why it is now being used for HPC. So that's how it evolved. So within 5 to 10 years, I think this kind of event will happen many times. So what we expected to happen once we reach FTQC, well, in the future, we will see something surprising usage. I hope that that will be the case. And so that was quite insightful view. Thank you. And so I also resonate with your opinion. A clean picture, what you expect, and roadmap. That is the evolution or improvement of what we have today, simply. So methodologically speaking, it is a 0 or 1, but what is not just 0 or 1? And so from the internet or from the digital, the GAFA was born. So quantum unique business that probably be created by someone for sure. And we hope some Japanese players can create such unique business. And so FTQC, and from the starting phase, and you've been only focusing on this. So Mr. Matsushita, you've been focusing on FTQC from the start. So what we should be doing now. Thank you. So my simple answer to the question is, well, quantum computer, what we have to do from now. My answer is not going to be a direct answer to that question. What concerned me when I heard about this question is more of a tool-driven approach that you have in mind. So problem should be the starting point. So it just so happened that it will be fit with good affinity with the quantum computers. For those who want to use a quantum computer now, what are the challenges? What are the problems? And then what is the best fit between the problem and quantum computer? And we are the ones to find that out for those users. And so if you ask, bring in the program or the issues that is best fit to be addressed by the quantum computers, people don't know. So doing things with a quantum computer is not the purpose per se. It doesn't have to be anything. So if you have any problem with the computer resources, please come to us. And if we believe there is a match between the problem and a quantum computer, we are willing to work with you. That's our approach. So 4 or 5 are the optimal number of problems. And then if you see it and you can find one which will be a best fit for the quantum computer. And so problem-driven approach should be highlighted more. And if you find out there is a problem that could be best solved by the quantum computers, and we can collaborate. That's our approach. Thank you. That is very appreciative idea. Because not you're trying to focus on the deals, but you think about the users and think about what actually matters, values. I think that was wonderful.
そろそろ時間になって
We are running short of our time, but lastly, I just want to ask Kitagawa-san. whether we should be using the physical machine. Yes, please do use the machine that is available today. Why is that? As Mr. Chi said, what we should be doing is to grow the market to say 10 times. We have to find killer application to grow the market. And Professor Todo also said that there may be surprise applications. And what becomes overwhelmingly important is exponentially we have to grow the market. We have to extend the range and width of solutions. Obviously, hardware will become fault tolerant and there will be growth. And at the same time, we have to have growing user community. There will be more users, they use more hardware will grow, and then user will also grow. So it's a very positive chain reaction. As a result, we will see the exponential growth of hardware market. It has already started, but we need to accelerate that change reaction. And Mr. Terabe, you're working on community creation. I think it is extremely important. Thank you. I appreciate your comment. So community is essential. Those of you who are here today, let's unite so that we will be able to make this exponentially growing market. Later on during networking, I hope you will have a passionate discussion with these panelists. I'd like to thank panelists and all the members in the audience. Thank you so much.